All right, so sometimes we want to store the history of your hidden states into some cache memory. And this is the idea of this article in 2022 by Intel company. Oh, by the way, Intel is now working on neuromorphic computing and using, for example, reservoir computing, and they are constructing a new generation of computers. Intel company as well as IBM company. So neuromorphic computing is the future of computer architecture. Forget von Neumann architecture. They draw inspiration from our brain, from biological systems. Everything is asynchronous. Everything is spiking. Everything is like a computing reservoir, that everything inside the reservoir is a neural networks that is achieved biologically. Or even you can implement it by photonic devices. So in this lecture, I'm going to be explaining the cache memory gated graph neural networks, which is a kind of GNN that uses external memory, but it is cache memory. And you know, cache is faster than RAM, and there is a purpose behind that. So what is the idea? We propose a memory augmentation to a gated graph neural network which simply stores the previous hidden states in a cache. So it stores all hidden states H1, H2, H3 in a cache. We show that cache memory gated GNN outperforms other models on synthetic datasets as well as tasks on real-world datasets that require long-range information. GNN assign each node a feature vector and aggregate features from a node's neighbors using a recursive message passing paradigm. So this is the classic GNN. After k iterations of aggregation, the resulting feature vector captures information from the node's k-hop neighborhood. You know, there is a problem with the GNN, and there is a bottleneck, and we call it over-squashing bottleneck of that. It means that distortion of messages being propagated from distant nodes. So this is a bottleneck. When we want to travel from this side to the other side, there is a very low probability if you think about it in terms of Markov chains and random walks. Ideally, a deep GNN with L layers would effectively aggregate information from a node's L-hop neighborhood. However, as L increases, the receptive field of a given node increases exponentially. This makes learning long-range dependencies in GNNs an even more challenging problem than in recurrent neural networks, where recursion causes linear rather than exponential increase in information that needs to be captured by some fixed length vector. And if you want to know more about over-squashing bottleneck, this is a very good article from Oxford. So their solution is to augment GNN with a memory. One way of tackling this issue is to augment GNN with some memory which can store information from more distant nodes or farther back in time. Advances in the design of memory mechanisms in other areas of machine learning, particularly in language modeling, suggest that this may be a rather effective way to make progress on long-range graph learning problems. So we propose a new memory-augmented GNN framework based on GGNN called cache memory for capturing long-range dependencies. They propose to store the past hidden activations of gated GNNs in an external non-differentiable cache memory and access them through a dot product with the current hidden activation. So there is a dot product with the current hidden activation. You store this is the history. You store all of the hidden states, and the rest of the thing is just classic, because gated neural networks. You update the gate like this, you reset it, and this is H tilde, which is used. This H tilde is used here to know the HT. So this is very important because you're summing all of the hidden states from previous times, because you have captured them in your cache memory, and because they are stored without any transformation to the hidden states. And there is a hyperparameter lambda here that shows how much of the next hidden state relies on memories retrieved from the cache. For example, if lambda is 0, then everything is relied on your cache. Cache is the winner. When lambda is 1, this term becomes 0, so remaining thing is the classic gated GNN. And you see that the precision, it has a higher precision. Memory graph convolution and also the gated